take a look at a real-world example where we can see velocities occurring at constant rates. So Arsenio leaves on a plane traveling from Chicago to Los Angeles. His plane travels at 540 miles per hour. 1 hour later, MC Plier leaves on a plane traveling from Los Angeles to Chicago. His plane travels at 660 miles per hour. Distance between Chicago and LA is 1,800 miles. The first question that we're going to face is how long will Arsenio travel before the two planes pass each other? And the second thing is, how far from Chicago are they at that moment? But let's sort of think through this because it's a tricky question with lots of rates. So here we go. I'm going to try to enact this for you right now. So at a certain moment from Chicago, we have Arsenio. It's going to take off and start to fly, heading out west to LA. An hour later, so an hour after we're in flight, all of a sudden, that's right, MC Plier comes flying out from LA. Can't touch this. And they're flying and they're heading toward each other. And the question is, at what moment will they actually pass each other, safely, by the way? And then the question is, what is the distance that they actually pass each other from Chicago? So this is a tricky question because there's so much going on, and there's music and pliers, and so it's a little bit tricky. But if we take it slowly and parse everything out, we can actually resolve this air travel question. So first of all, let's just draw a very simplistic version of a picture so we get a sense of what's going on. So here's my version of a picture. Here's Chicago, and here is LA. And what do I know? I know that Arsenio is going to start from Chicago and head over to LA, and that he's going to travel at a constant rate of 540 miles per hour. Now, while he's an hour into the flight, MC Plier takes off at a constant rate of 660 miles per hour, heading toward Chicago. So the question is, when are they going to pass each other? So they're going to pass each other at some point. Let me mark that point right here. Let me call that distance away from Chicago where they actually pass each other D. So I'm going to let D denote that distance. And what time will that be? How many hours will that be from the time that Arsenio starts? Let me call that time T. Okay, now let's view the world now from MC Plier's perspective. Okay, when MC Plier gets to this point, well, what's the distance that he has traveled? Well, we know the entire distance. This entire distance is given. So if Arsenio has traveled D miles, then this is the difference. So this length right here, we know 1,800 minus, that's this length right here. And what about the time? Well, we might say, well, the time is the same, it's T, but remember it's not, because in fact, MC Plier left an hour after Arsenio. So if Arsenio traveled for T hours, then that means that MC Plier traveled for T minus 1. The time here is going to be T minus 1, that's the time. Now, we can put all this information together if we remember one of the most important formulas that involve change. That distance equals rate times time. And so that means that if we insert the data for Arsenio and we insert this formula, the data in for MC Plier, we will have a lot of information that we can analyze. So let's first of all do Arsenio. So Arsenio, we know that distance equals rate times time. He traveled a total of d miles, so we have little d equals the rate. His rate was 540 miles per hour times the time, which is t. Now, what about MC Plier? Well, MC Plier traveled a distance of this. So that's the quantity 1,800 minus d. And that's going to equal his constant speed, which was 660 miles per hour, times his time, Now his time wasn't t. Remember, he started an hour later, so his time was t minus 1. Well, now we still have lots and lots of things that we don't know, but we're trying to find t. So we want to solve for t. So the thing that I would do actually is take this information about Arsenio. See that d there? It equals 540 t, and I'd insert that in for this d. So let's substitute this for this, which we can do since they both equal d. If I do that, here's what I get. I see that we have 1,800 minus 540t equals, and let me actually distribute here, I see 660t minus 660. Now I can actually combine terms here a little bit. I can add the 540t to both sides. When I bring that to this side, I'm going to see here 1,200t. And if I add 660 to both sides, it'll drop out of here. And when I add it to this side, I'm going to see 2,460. And now I can solve for t by dividing both sides by 1,200. And so I see that t equals, after I cancel, I see that t equals 123 divided by 60, which, if we write that out as a mixed number, turns out to be 2 and 3/60ths, which means that when do they meet? From the time that Arsenio started his flight from Chicago, 2 hours and 3/60th of an hour, which is basically 2 hours and 3 minutes. So the answer is, first question was, how long will it take Arsenio to travel before the two planes reach each other? It's going to be 2 hours, 3 minutes. That's the answer to the first part. The second part of the question asks, how far from Chicago are they at that moment? Well, that's asking for this distance right here. So it's saying find little d. But we can do that just using Arsenio's formula. We know that d equals 540 times t. And at that moment where they meet, we know that's going to happen at t equals 123 over 60. So I insert 123 divided by 60. And when I simplify that, that comes out to be 1,107 miles from Chicago. So this was a very tricky question that involved a lot of constant rates. But when we remember that distance equals rate times time, it turns out that even a question like this, you can touch this.